Okay, so this is problem number 18 from Hall and Knight Higher Algebra, Chapter 1 Ratios. We have been given three equations. X is equal to cy plus bz, y is equal to az plus cx, z is equal to bx plus ay, and we have to prove that x square over 1 minus a square is equal to y square over 1 minus b square is equal to z square over 1 minus c square. So let us rewrite this equation. So equation number one is x minus cy minus bz is equal to 0. Equation number 2 is cx minus y plus az is equal to 0. Equation number 3 is bx plus ay minus z is equal to 0. Now from the first two equations we can find the relationship between x, y and z ratio by the rule of cross multiplication. So that will be x over you have minus c times a is minus ac minus 1 times minus b, so that is plus b, so it will be minus b is equal to y over minus b times c, which is minus bc, and one times a minus a is equal to z over you have 1 times minus 1, which is minus 1, and you have minus c square. So minus c square will be plus c square. Now this can be written as x times b plus ca is equal to y times a plus bc is equal to z times 1 minus c square. We have simply multiplied each of these ratios by minus 1 and we will get this. So we know this relationship will be true from equation number 1 and equation number 2. Now let us consider equation number 2. Let us consider equation number 2 and equation number 3. So now we will consider different set of equation. Let us say that we are now comparing equation number 2 and 3. So what will we get from 2 and 3? We will get x over, okay, this we have minus 1 times minus 1, which is 1 minus plus a 1 minus a square. okay, is equal to y over a times b minus c, so that will be plus c, is equal to z over c times a minus b. So ca plus b. So now we have second relationship over here. Let us call this one as some constant k2. Similarly, let us call this one as this one is k1. Now as a final step, we will consider equation number 3 and equation number 1. Okay, so now we will consider equation number 1 and we will consider equation number 3. So from this we will get another relationship which is x over, now this is minus c times minus 1, which is c, minus plus a times minus b. So c minus ab is c plus ab, is equal to y over, this is minus 1, sorry, this is minus b times b is minus b square minus 1 times minus 1. So 1 minus 1 is minus 1, so minus 1 is plus 1. Is equal to z over a minus b times minus c is minus bc, minus bc is plus bc. Let us say that this is k3. Now let us look at what we need to prove. What we have to prove is, we have to prove that x square over 1 minus a square is equal to y square over 1 minus b square. We can see that x square over 1 minus a square already exists in the second relationship over here, and y over 1 minus b square is over here. So let us find out. Let me use another color. Let us say what would be the value of k2 times k3. k2 times k3 can be written as x square one minus a square c plus ab. How did I get this? I just multiplied this term and this term. Okay, but this is also equal to y square into 1 minus b square into c plus ab, because we can multiply these two terms also to get k to k3. So now we see that if this c plus ab and this c plus ab cancel each other out, assuming c plus ab is not equal to 0. Okay, so now we have already proved that this relationship we have already proved. Similarly, if we can prove that x square over 1 minus a square is equal to z square over 1 minus c square, then our job will be finished. So how can we prove that? Now we see that z over 1 minus c square is already there in k1. So let us find out what will be the value of k1, k2. Okay, so k1, k2 will be, we take this and multiply by this, so we get we take this one and multiply by, that is, we multiply these two, k1, k2. So we get x over one minus a square, okay, b plus ca is equal to, we multiply this and this is equal to z square over 1 minus c square b plus ca. So again we can cancel b plus ca. So assuming that b plus ca is not equal to 0, we get x square over 1 minus a square is equal to y square by 1 minus b square is equal to z square over 1 minus c square, and we are done.